Do I need to do anything on the computer to get it on YouTube, or you have
No,
everything
it's
on the
all here, but it's not working.
Okay.
Yeah.
Yeah.
So the technical company is trying to fix it.
Okay. Yeah. Just let me know if you want me to do anything.
Thank you. Þetta virkar núna, Guðbjörg. Það mjútaður? Heyrir hún ekkert í mér? Ekkert. Já, við syngja verið boka. Við taka hérna ungbæðarsinslögin. Hvað segir boka? Heyrist? En ekkert svanaldur. Er eitthvað hérna? Já, ekki að vera hérna.
Yeah.
For the YouTube viewers.
Yeah.
Might prova hérna.
Will you say anything first?
Yeah, I will start the introduction.
Heyrist eitthvað betur hérna, boka?
Boka er sem stödd á Spáni.
Það er ekkert frí í búið þessari deild.
Hún heyrir,
Ok. Og notum við bara, heyrir hún hér líka? En hérna, boka?
Allt ok.
Ok.
Ok, frábært, þannig að það bara plana. Já, komið sæl og velkomin. Guðbjörg heiti ég og ég þar til mjög nýlega vann hjá Rannsóknarsetri Háskóla Íslands vestur á Fjörðum, en ég vinn núna hérna á botnsjávarsviði Hafró. Við Jan kynntumst í gegnum svona kostverkefni merkingar og rannsóknir og ferðum á dýrum í sjó og vatni. Einhvern tímann á einum af þessum fundum þá erum við samferða í rútun út á flugvöll og ég bað Jan að segja mér svona stuttlega frá því hvernig þetta virkaði allt í Noregi. Og eftir ég sá þá kynningu þá segja okkur við verðum eiginlega eins að fá tækifæri til að nýta okkur þessa þekkingu. Jan hefur unnið mjög mikið með að á þessu svona svæði samspili á milli þá fræðilegra vísindarannsókna og mjög hagnýtra rannsókna í að kanna áhrif af hinum ýmsu framkvæmdum og verkefnum mannanna á fiska og fyrst og fremst kannski á göngufiska og hans svona megin tegund urriði eða sjóbirtingur en líka með aðra fiska. Og núna í sumar, segir nú líka hvernig hérna típan við rættum í þessari sömu rútuferð að vera nú kannski gaman að vinna eitthvað saman með þorska þegar ég var með rannísverkefni að skoða ferðir ungviðis af þorski í íslenskum fjörðum og þetta endaði allavega þannig að það synda núna þorskar í við Noregsstrendur sem að hérna eru merktir af þessu rannísverkefni. Þannig að hann lætur svolítið svona hlutin að gerast og ég sé hann skilur ekki orðaði sem segir sem betur fer en hérna en þannig ég ætla bara að leyfa verkum hans að tala fyrir sig sjálf. Gjör svo vel, Jan.
Thank you. Thank you very much. I hope you said something good. My name is Jan Grimsrud Davidsen. I'm a research professor at the Norwegian University in Trondheim. And together with me today is Sindre, a postdoc. And we have been working together on brown trout, and mostly in Norway for the last 11 years. But we are also dealing with Atlantic salmon and Arctic char and cod. And today I'll mainly focus on the brown trout, but a lot of the things we are doing can also be related to Arctic char. So when we say brown trout, you can also think Arctic char. A lot of our job is related to the management and the industry in Norway, because in Norway we have a lot of trouble with, for example, aquaculture, fish farming, but also other kind of human activities in the coastal zone. And these problems are related to that it have an impact on the wild fish. So as we go through today, you will see that a lot of our stuff is related to that. I guess most of you are familiar with the brown trout and Arctic char, but just to be sure we are on the same page, I always show this figure when we start our presentations. Arctic char, brown trout, Atlantic salmon are all born in the freshwater system. That's the system we have up to the right. And after a couple of years, they have several options. The Atlantic salmon, most of them will migrate down to the river mouth, the estuary, and they will continue out to the open ocean for a feeding migration. The brown trout and the Arctic char, they are a bit more complicated fishes. They may migrate down to the river mouth, and some of them will just stay there during the whole feeding season. They don't have to go out to the sea. They can just hang around in the estuary for months, and when the winter comes, they may stay in the estuary for overwintering, or they may go back to the river for spawning or for overwintering. Some of them will continue out to the more marine part. Maybe they'll stay in the fjord or will go the whole way out to the open sea. Stay there for weeks or for months, and when they're happy, they'll come back to the estuary. Maybe they'll overwinter in the estuary, or they'll go back up to the river or the lake and overwinter there. And of course, some of the Arctic char and brown trout will just stay in the freshwater for the whole life. And it can be brothers and sisters. Like the younger brother may have the option just staying in the freshwater system during the whole life, while the older sister may migrate out to the sea and be anadromous. So if we focus on those fish that actually leave the freshwater system, there's a lot of potential problems between the marine feeding migration and man-made installations. This migratory lifestyle does very often bring individual sea trout into areas where we have anthropogenic activities, such as sea cage salmon farms, marine renewable energy, and other kinds of coastal infrastructure. And in general, the biology and ecology of sea trout, and probably also of Arctic char up here in Iceland, at sea is poorly understood. However, sea trout is an important ecosystem service in many coastal areas. A lot of people, especially in Norway, like to go fishing for sea trout. A lot of people like to know that there is a healthy sea trout population, even if they don't go out fishing for it. It's very important for them to know that we have sea trout in the rivers and the fjords. A lot of people are selling fishing licenses for people who want to fish for sea trout. People are renting out boats. People are renting out small cabins so that people can come and fish for the sea trout. So in many different ways, the sea trout is an important ecosystem service. And because of that, detailed information about marine migrations and habitat use is important information for stakeholders during planning processes for coastal zones. So in 2011, we started the research program we call The Secret Life of Sea Trout. And during the program, we are combining several methods to get our answers. We use acoustic telemetry to track marine migrations and habitat use. We use video monitoring and pit telemetry to study migration timing, return rates. Radio telemetry to track freshwater migrations. Stable isotope analysis to study marine feeding ecology, previous marine migrations. And laser ablation to study trace element concentrations in fish scales. So depending on the questions we are working on, we combine these different methods. So during this last 11 years, 12 years, we have tracked sea trout, retrans, and post-smolts from 16 different watercourses in 5 different fjord systems in Norway. And we also tracked Arctic char, Atlantic salmon, and Atlantic cod, but the main focus has been on the trout. The observed individual marine behavior is typically linked to morphology of the watercourse. Is the sea trout coming from a river or from a lake system? The physiology, we are doing blood sampling. Previous life history based on scale readings. Pathogen loads based on gel biopsies. Environmental variables, typically salinity and temperature measured by Staodi data loggers. And genetics. We take DNA from all our fish so we can determine the sex of the fish. Also, sometimes we do population genetics. Additionally, we want also data from more isolated populations that are not impacted by human activities. So we have tracked Arctic char at the Kerguelen Island in the southern Indonesian Ocean, one of the most remote islands in the world. And we have tracked Arctic char at southwest Greenland. The method we use is typically acoustic telemetry, especially when you are working in the marine environment. And for those of you who are maybe not so familiar with that method, it means that we take a small acoustic tag, we insert it into the body cavity of the fish. The tag will transmit signals more or less once every minute, depending on how we program it. And the data will be recorded by acoustic receivers deployed out in the marine environment. Sometimes we take our boat, we go out and take the receiver to the surface, and we download the data from the receiver to our computer. We go back to our lab or our office, and we make a lot of coffee, and we start analyzing the data. This is a typical field design. This is in Tosenfjorden in northern Norway. All the red symbols are acoustic receivers in the marine environment, and the green one are receivers in the freshwater environment. So we typically deploy the receivers in gates, so if the fish is moving from one part of the fjord to another, it will be recorded in the gate. And so we can have the receivers out for a couple of years. We will have to change batteries once every year, but often we are tracking the fish for 2 or 3 years in the fjord system. When we are, a lot of these projects are related to coastal zone planning. The county governor, the management regime, or maybe the aquaculture industry needs data about how the salmonids are using the fjord. Maybe they are applying for an increase in their production in a special part of the fjord system, and the management regime tells them, before you can get the permit, you will need to show us how the sea trout is using the area. And if we can see that the part of the fjord where you want to increase the salmon production is important for the salmonids, it might be that we will not give you the permit. So we actually have to document how the fish are using the area before we will get the permit to increase the production size. Other projects are related to land reclamation, for example in estuaries or fjords, and that can be due to construction of harbors, airport runways, highways, or development of industrial areas. And we are always publishing our data in public technical reports in our reports area. So, of course, the industry will get a copy. That's what we are paying for, but it's also public for everybody else. So there's no secrets. And normally we will have an English summary. So if you're interested and you don't speak Norwegian, you can also at least see the summary. We typically create a map showing how the fish are using the fjord system. Here you can see all the receivers. They're indicated by a round circle, and each receiver will have a different color. And the color depends on how many fish that have been recorded on this receiver. So this map here is just showing an overview for the whole year. Typically, we will make maps showing how the fish are using the area month by month. So we can see, for example, in February, there was no fish out in the fjord. But in July, the collars on all the receivers were very brown. So we could see, okay, the sea trout used actually the whole fjord system in July, or maybe only a part of the fjord system. So when we visualize the fish data in this way, it's very easy for the stakeholders to go in and see which part of the fjord system is important for the sea trout or the Arctic char, and in which parts of the year is the fish actually out here. And especially the last thing, the temporal thing can be important if they want to plan for delicing. During which parts of the year will it be more important to have a very low level of sea lice in relation to wild salmonids. One of the main things we see in all our studies is that the marine residence time clearly depends on the morphology of the freshwater system where the fish belong to. The picture to the left represents a nice deep lake. It's 80 meter deep, and during winter there will be 1 meter of thick ice. The picture to the right represents a small creek. Here we have very fluctuating levels of freshwater, and during the winter the ice will freeze and melt and freeze and melt, so it's very unstable. So to the left, the picture to the left, the lake is very nice overwintering habitat, but the small creek is not a very nice overwintering habitat. And when we track the fish during the summer season from these two habitats, we can see that fish from the lake habitat, they use the marine habitat for about 2 months during the summer season, while fish from the river habitat, they are out in the fjord during the whole summer. It's even more interesting if we look at the whole year, because fish from the river, they seems to be out in the marine habitat or in neighboring habitats all year round, except for the spawning season. So we are just up in their own small creek during the spawning time, and when they're done at the spawning, they will go down to estuary and stay there, or maybe use the fjord a little bit more, or they will cross the fjord and go up in a neighboring freshwater habitat with a lake system where it's more stable to overwinter. So in a lot of our fjord systems, we see that if the sea trout only spawning in a small creek, they will not stay in that creek for overwintering. They will move to neighboring watercourses or will stay out in the marine environment during the winter. And it's very important knowledge if you are evaluating how many fish you actually have in a special freshwater system, or if you are using catch statistics, because maybe the catch statistics from one river is not only representing the fish from that river, but also fish from other rivers that are coming up into the river for overwintering. Estuaries seems to be very important for sea trout. Within the same population, some sea trout may stay in the estuary or the river mouth during the whole feeding season, while others, they may only feed there for some days or weeks on their way or out to or back from the marine feeding areas. And Sindre published a paper not so long ago where he showed that physiological state, the condition factor, the body mass index of the fish in the spring, the sex of the fish, and the body size differs between these two migratory strategies. So low body condition in spring, and especially females and larger body size, those fish were more likely to migrate to sea. So to make it a bit popular, a long, thin, very nice female fish is more likely to migrate out and to explore the world, like a smaller fat male will be home close to the river and maybe move 1 or 2 kilometers away from home river. Low condition factor in spring and larger body size was typically related to earlier marine entry in the spring. Low condition factor in spring and a larger body size was related to a longer marine stay. And low condition factor in spring and larger size were related to longer migratory distances. So it seems like sea trout that are low in condition factor, they have more to win if they actually migrate out to the more pelagic parts of a fjord system. They can go out there and they can feed on pelagic fishes, and we can have a better growth. And especially females have more to win for doing that. It's a risk to migrate away from the home river. There's a risk of dying, a risk of parasites, diseases, predators, but there's also a gain. And for slim females, this gain is higher than for small fat males. So it's about risk taking. The marine residency period is also a function of pre-migration physiological condition. So in this paper here, Bordelot, a PhD student from Canada who came over to Norway and had a stay, he showed that fish were low in body condition in the spring. We also stayed longer at sea than fish that had a higher body condition in the spring. Sindre have shown in another paper that individual brown trout display significant interannual consistency in marine area use and in the timing of marine exit. In other words, when the timing when they return to the spawning river. But there was no repeatability in the timing of marine entry or the time spent in the marine environment each year. So it seems like that the time that the sea trout leave the river more depends on environmental variables, but the time that we go back to the river is a kind of fixed thing. So if sea trout have a behavior 1 year, and maybe that behavior brings the sea trout into areas with problems like sea lice or diseases, there's a big risk that the sea trout do the same again next year. It seems like they're doing the same year by year. So why is this important? Why is this information important? Well, it's important for us to know that sea trout, they move far away from the home river. They have a higher chance, or they're increasing the risk of negative influence from open cage salmon aquaculture. If they just stay in the river mouth, they'll typically be some distance away from these sea cages. But if they move out and explore the whole fjord system, at least in Norway, they will very often come nearby areas where you have open salmon aquaculture. What we see in our studies is that the stays around the sea cages in general are short. And there's no indication of attraction of sea trout to fish farming areas. However, sea lice from fish farms may negatively influence sea trout so far as 30 kilometers away. So if you have a fjord system with intensive fish farming, if you have trouble with sea lice, if the sea trout is moving around in that area, there will be a negative impact on the sea trout, even if the sea trout don't come very close to the fish farms. In an ongoing project called PACE, led by Norse Research Institute in Bergen, we are studying the role of pathogens on the individual behavior and survival of sea trout across a latitudinal gradient. And Sindre is doing his postdoc on that project. So if you want all the details, you can ask him tonight. But we have some research questions we are looking into. What role does pathogen burden play in the fate of wild sea trout? Is individual fate linked to up or down regulation of stress and immune-related genes? And is pathogen burden associated with oxygen uptake and activity levels of free-swimming sea trout? And does this interact with temperature? So here we are not focusing just on sea lice, but on pathogens in general, bacteria, viruses, and other kind of parasites. And we are collecting data from all over the coast of Norway. And so we are doing telemetry studies on sea trout from 3 different fjord systems, one around Bergen in southwestern Norway, one just outside Trondheim, and one up in northern Norway. And in addition, Sindre have done some respirometry experiments to look into oxygen uptake and energy consumption for fish with different levels of pathogens. We are not only working on problems related to fish farms, but also to other kind of constructions in the coastal areas. This picture here shows you the plans of the construction of a new highway between Trondheim and the Trondheim Airport, Værnes. And they want to fill up a part of the estuary because of this highway construction. The fjord, the Trondheim fjord, is a national salmon fjord. So, and the river coming out from the right is a protected salmon river. So in theory, it's not allowed to fill up this river mouth. But anyway, the Prime Minister already been there and start digging and say, now we build a road. But then they were forced to ask us to document how the salmonids are using the river mouth so they can plan for compensatory measures. So if we show that this area is important for sea trout and salmon, we have to make some compensatory measures. So for 1 year, we tracked around 500 fish in this area, both Atlantic salmon and sea trout. And our report clearly showed that the area we want to fill up with gravel and stone is important, especially for sea trout. So now we are working on suggesting compensatory measures. How can they create a new habitat similar to the one that we are going to destroy? Another thing we are doing is that we are tracking in real time the behavior of the fishes. This map here shows the study design. All the red dots are the standard acoustic receivers, the one that are just out there and we are collecting data, and sometimes we go out and download the data. But in addition to these receivers, we have also live stations providing us real-time data. So if I go on my cell phone now or on my computer, we can see what the fish did 2 minutes ago. And the idea behind that is that when, probably next year, we start filling up a part of the river mouth with gravel and stone, we can see if the fish are negatively influenced by the work we are doing right now. And if we see that there's a huge impact on the fish, we can call the company and we can say, you have to change the way you're working right now. Maybe you have to install some bubble curtains or do other things, because right now you're scaring the fish like hell. Sorry for language, but that's the idea. The data we get from the real time system is like this. On the upper figure, we have swimming depth. On the central figure, we have the activity, and the lower part, we have the temperature. So if we see that there will be some peaks, especially in activity and in swimming depth, we can see that something is going on. And if this goes on for a little while, okay, there's a problem here. So now we have already 1.5 years of background data, so we know what is the normal situation, and we will use this as a reference when the construction work will start up. So this is first time this is being used, as we know, for this kind of work. But if we succeed, we think that this can be very useful in other kind of work. Like when people are doing pile driving or whatever they're doing in the coastal zone or in a river. Instead of mapping the fish behavior before and after, we can actually do it in situ, and we can stop the work and we can give advices how we can change that before it's too late. So, as I said, we also need data from more undisturbed areas, because we can argue that Norway is not a very pristine area, even there are few people living there in a big area. We have a lot of impacts along the coast. So a couple of years ago, Sin and I got the chance to go down to Kerguelen Island. At the lower part of the map, you see Antarctica, and you see Australia and Southern Africa. You go by plane to Reunion Island, and you drive 2 weeks in a big boat, and when you are down there. So down there, we tracked sea trout for 1 year. Between 1951 and 1991, 8 species of salmonids were introduced to this French archipelago. This previously were devoid of any freshwater fish. 3 species failed to establish local populations, but salmons, as Atlantic salmon, established a landlocked population, while the brown trout, brook trout, Arctic char, and the coho salmon established populations with different levels of anadromy. Brown trout were the tough one. That was the one who actually managed to colonize a lot of new rivers down there. The other species were more or less concentrated to the rivers where we were brought into by human. So, but on the northern side of the main island, the colonization seems to slow down of the brown trout. So we are very curious to figure out why do the brown trout don't move into new freshwater systems up there. So we deployed acoustic receivers, and we tagged 50 brown trout with tags that can measure salinity and temperature. So it gave us the idea of the fish, the surrounding salinity, and the surrounding temperature. And we tracked the fish and we followed them for 1 year. And the penguins were very curious about our work. We were not used to that. The conclusion was that the sea trout moved very short distances away from the river mouth, both the males and the females. We could see that they had plenty of food, they were in a good condition. And we know that out in the more marine area of the fjord system, there's a lot of predators waiting for them. So our conclusion is that most likely they don't need to move out there because they have plenty of food. So it's no need to take a risk. And that could be the reason why they don't find new watercourses along the coast. So they just stay there because it's fine. They don't have to move. Yeah, so back in Norway, we work also with salmon and Arctic char, even if I've mostly been chatting about sea trout today. We have been working a couple of times in Greenland. In 2012, we did a study on the only known spawning population of Atlantic salmon in Kapellskjær, close to Nuuk. And we also looked at the marine trophic issues and life history diversity among Arctic char in 3 different watercourses in southwestern Greenland. Last year, we went back to southwestern Greenland again, down to Nanortalik, and we did a telemetry study in a fjord system. So we captured a few hundreds of Arctic char. We tagged 85 of them with acoustic tags with a temperature sensor, and the rest of them we killed and had for dinner or lunch or breakfast. And we did samples for stable isotopes and DNA. Beautiful area in southwestern Greenland, I recommend it. We used acoustic receivers with a release system. You cannot leave receivers out for 1 year and think they are there still when you come back next year. So you put them at the bottom of the fjords with nothing at the surface, both to avoid problems with drifting icebergs, but also Greenlanders being out there and wondering what's all about. And when we came back this summer, we got all the receivers to pop up to the surface again, and we downloaded the data. And when we come back and we get closer to Christmas, we will start looking into our results. We see we have a lot of good data, but we have no time to look at them yet. Finally, we have been to the island of Jan Mayen a couple of years ago. We did a gill netting study or survey in the only freshwater lake that don't dry up on Jan Mayen, Nordlaguna. The smart geology guys at our university, or not our university, but a research institute in Trondheim, they figured out that the lake had a connection to the sea until 732, but because of volcanic eruption, this connection was blocked. So from 1732 and until now, the population have been landlocked. Right now, we are trying to figure out the origin of the population, so we are collecting DNA samples from Arctic char around Jan Mayen, and hopefully also here from Iceland. And so we will try to see what is the history. For the salmon in Greenland, we figured out that they came originally from Europe, not from Northern America. And we already have some indications also that the Arctic char in southwestern Greenland origin from Europe and not from US or Canada. So we expect the same as the situation for the Jan Mayen population, but we are keen to figure out if they are from Iceland or from Spitsbergen or maybe from Norway. So hopefully we can figure that out next year. Yeah, just some pictures from Jan Mayen. I guess it looks familiar to Iceland. So finally, during our work, we have a lot of communication with the stakeholders and the public. And we have a kind of philosophy around that. Working with anthropogenic impacts on salmonids in Norway is a minefield. As some of you may know, there's a lot of people that don't like to hear the results. But by involving all parties with an interest, for us it seems like that it became easier to get the public and the other stakeholders to buy into the project, the data, and the study conclusions. So consequently, most of our projects have funding from both the management regime, the salmon farming industry, hydropower companies, landowners, and game fisher organizations. Obviously, landowners, we only have a small share in the project, and the fish farmers, we can have a big share, but all have a share, meaning all can meet around the same table, and we can have good discussions already before we start the project. And when we have these discussions both before and during after the project, it's much easier to get them to accept what we have been doing because they know what we've been doing the whole way, the whole process. And all interests are invited to informative meetings both before, during, and after the project. And all technical reports, master and PhD theses, and scientific papers are actually forwarded to the involved partners. So it's all public what we are doing. We address our communication to 4 identified target groups: the local, the management regime, both national, regional, and local; the sea cage salmon farming industry, and of course, if we are working in other projects not related to sea cage salmon farming industry, it's that actual industry we are working with. So local landowners and game fish organizations, and children from youth schools. With background in updated knowledge on sea trout ecology, we give advice related to, for example, coastal zone planning, and that could be location of new salmon farms and other coastal infrastructure. I'm chatting with the management team in Norway every second week, every third week. They just call me just to give an advice. It can just be a very informal phone call or an email just because we need some information or just some advice on how to do some things. And we are monitoring sea trout populations. So we are using video cameras in rivers. So we're counting all sea trout, salmon, Arctic char coming up every autumn. So we can give advice on how healthy the populations are. The sea cates, the salmon industry and the landowners and game fish organizations, we invite them to all the meetings, but they also assist us a lot in the field. The fish farmers will help us with boats. The local people, they can also help us with boats, or they are maintaining our equipment, we are looking after our equipment. Sometimes we call us, oh, we found one of your receivers on the shore. I know it should be another place, so I just put it back. Everything is fine, I just want to tell you. So that's one of these positive things about involving them. And so we try to give local ownership to the projects. And again, if we have local ownership, it's easier to get acceptance for what we are doing. And so we invite school classes, kindergartens to visit us when we're out in the field. So typically they will come for a couple of hours. We will tag teddy bears with radio transmitters, and we can go around with the big radio antennas, and we can try to track them down in the forest along the river. We maybe have some fish, so we can open them and look into them, and we try to tell them about the fish and what we are doing. And the good thing about bringing out the kids is that when they come back to the municipality where they live, they will tell their parents, or grandparents, and the neighbors. Within a week, everybody will know what we are doing. If we invite to a local meeting, there'll be 2 or 3 people showing up, and nobody will know what we are doing. But when we invite the kindergarten or the school class, everybody will know about the project. And for sure, the kids will own the project, so if people are doing some stray things, we will tell them not to. So we think it's a nice way to do it. And also, we need new students in 10 years. So by that, I, as always, like to thank everybody who is involved in our projects. If people are not involved, we could not do our projects. We need funding, just like you do up here in Iceland. So I'm here because we want to strengthen the collaboration between Iceland and Norway, and especially between the Marine Institute and the University of Iceland and NTNU. And the trip out here is supported by something called the European Tracking Network. It's a cost initiative, so it's supported by the European Union. And the idea is that everybody working with acoustic telemetry in Europe should share the data. If you take a salmon here and it swims to Norway, you will be happy to know about it. So if it's picked up by my receivers, I should let you know. And we do it that way, that we have a central server someplace, I have no idea where it is, but we upload all our data to the ETN system, and you upload all of your data, hopefully, to the same system. And if there's a match between my recordings and the fish you have tagged, you will know. And that's the way we can share our common infrastructure. And I think that's a very smart way to work. Finally, I just want to say that we really love international cooperation. So I hope that the week we are up here now can be very fruitful. Thank you very much.
Thank you very much, Jan. Honestly, I find this even more fascinating now than when you told me this, part of the story in March. But I'm just going to open up for questions. I'm sure people here have some questions. Oh, Anja?
Thank you for your presentation. I love the active tagging. That's so cool that you can see what the fish are doing right now. I'm just thinking about all the projects you're doing all over the world. And if, for example, in Greenland, I would like to join, for example, tagging acoustic cod at the same time when you're tagging salmonids, what would you think would be a good platform for knowing about which projects are going on, what research is planned, and potentially me joining this research or anyone else? What can be done there?
I think the most important thing is to build networks like we do now. and travel around, chat with people, show the no-pass meetings, and be actually involved in what you're doing, and chat with people. Sometimes people think that we should make a homepage and everybody should put up a project, what we're doing, but it never works in reality. What works in reality is to build networks and take part in the no-pass meeting. That's a forum for PhD and postdocs, and chat with people. Come to the trekking conferences, stuff like that, and tell me that you want to join me for Greenland next year. And
Yes, please.
We are planning a new project next year, and as long as you can afford your own travel cost, you can come and take all the cut you want.
Cool. Good to know. Thank you.
Yeah, I also would know. Any other questions? Kalina?
Hi, I'm also stuck on the live stream. It's so cool, especially now after the summer, knowing how much work it goes into downloading the data from the receiver when you have to pull it out. What is the system that you're using in the live stream?
Telma Biotel.
Oh, okay. Another thing, when you were saying that within the same family you have migratory and not migratory, have you tried, because you have the genetic data, to actually look into outliers and see whether you have a genetic signal of like which fish would become migratory? Even though they're siblings, they might have some regions that are probably behavior or something like that, or metabolism that would be defining this. Have you looked into the data?
No, we haven't. We have tried to get funding to do it, but we are not succeeded so far. But I know more genetic labs have been looking into it, but typically we have the DNA, but we don't have the good migratory data. We don't have the telemetry data. So we have both. So some of you are smart enough to look into the DNA. We have the DNA in the freezer. Yeah. So. Yeah, so we have the telemetry data, and we have a lot of DNA in our freezer. Just we didn't have got the funding. So let's chat more about that, because that would be really, really cool. Yeah.
Thanks. Any other questions? Well, we will have more time to discuss today, but I have many questions. I could ask about just the details of this between individual variation and migration and all of that. But I think I'll just start with a very big question. I mean, it's lovely to have all of this data, but you're tagging hundreds of fish for many, many years using the best technology. How about the funding? So I think your funding system is brilliant, how you sort of use all of these avenues open to you, but that must have been a lot of work, networking and building these stakeholder networks. Can you share some insights on that?
We did, as I think you are doing right now. We started in the very small thing, and we tagged few fish, and we just tried to show that we know what we're doing, and it can be very useful for you, what we're doing. And then they learned, and they could see, yeah, this can be useful. Especially the management regime learned a lot about what we did the last 5 years. And now it seems like it's easier, and now we more often got a phone call that people actually have some money and they want us to do something. Before it was more we had to phone and ask 20 different partners if they want to put in some money. So it seems like easier. But you have to learn people, and you have to learn the industry, you have to learn the management regime, that this can be a very useful tool.
Yeah, I guess this is comes down to communication, because I assume that all sorts of impacts we would have to know about what the fish are doing out there, and I just share that, like going out with the gill netting service, for example, it's a much worse method than just tagging the fish and monitoring.
One of our projects, it was related to the construction of a new harbor. And initially, a private consultancy company were out doing some gill netting because they thought that would be a good method. But the management regime say, no, this report is not good enough at all. And so the harbor had to pay us the year after to do a better job using telemetry, because they have learned that would be much better. The data would be much better than just gill netting.
Okay. Well, I hope this talk will be one of those, bring us a step closer to that here in Iceland to understand how. But I see that Kalina has another question.
Sorry, a very quick one. We are noticing in Thingvallavatn that because we don't have this ice that you're talking about in Norwegian lakes, we don't have it anymore. So we see crazy fluctuation in temperature. Do you see the ice reducing over the winter time, or you still have this nice cushion of 1 meter of ice in your lakes?
So the ice disappears in the spring.
Yes.
Yeah. And it come back again in December, January.
We don't have it anymore.
No,
Like it doesn't freeze over.
So if the ice gets thinner in the winter, probably yes. I don't remember this thing right now, but we see in general temperatures is going up in Norway. And we have more unstable winters, more rain, more wind, more periods with flooding and stuff like that.
Do you see it in the telemetry data where the temperature in the lake like goes crazy?
I
up
haven't
and
really
down?
looked into that, but we have the data. That's a good thing, you have a lot of data. Yeah.
Yeah, Michelle?
I just have a question about the study that you mentioned with the comparison between the lake and the river. Is that an indication also that the populations that would utilize those river areas where they weren't doing as well as comparable to the lake, does that mean that they may not use that river over time, or those rivers over time?
So if the river population is not impacted by human activities, I'm sure we'll do well. Just that we can't overwind up there. So it's a kind of their strategy. We have probably done that for thousands of years. They just move to a better overwintering habitat, and when we go back for spawning. Okay. But if they are impacted, of course, it will make trouble.
Yeah. Okay.
One of the things I didn't mention at all, because I thought it would take too long, but I can do it now because you're still sitting here. In the future, we want to use sensors that can measure different kind of physiology. Because now we can easily track the fish. We can see what we are in the fjord system. We can see what we are doing, swimming depth activity. But it's very hard to explain why we're doing it. What is the reason? So we have been discussing with Stauri already. Can we measure heart rate in the future and get the data transmitted to the receivers? Right now it's data loggers, so you need to recapture the fish so you can get the data log out. But if the data can be transmitted actually to a receiver, you can have free swimming fish, and you can just buy 1 million receivers and fill up your whole fjord. You can get your data. Maybe it can be hormones or other things. I know people are working on that as well. So you can get information about the hormonal states in the fish. So there's a lot of things where we'll move on. For the next 10 years, I think we will see a lot of new fancy tags coming up. And I think that will help us a lot. Noise, aquatic noise is a big problem, probably also in Iceland. How do fish react on aquatic noise? Oil and gas exploration, like using the seismic air gun, pile driving, all these things. How do the fish react on that, both cod and salmonids? A lot of things we should look into.
Yeah, very exciting years ahead. One more question, if someone has a question. No. Okay, then I just want to ask the final question. So of course, how, because you have a lot of experience, you've been working in very many different systems. So for us now planning or looking into impacts of some sort of development, how applicable are previous results? Can we say that because you find this pattern of, let's say, lake and small river or small stream trout, we are most likely, or we should expect the same here, so we can just transpose your results on our systems? Or is it necessary to repeat this in every system?
We have the same question in Norway. Now you have done it in 3 fjords, so why do you need it to do in fjord number 4? We see big differences between the fjords. So we argue that in Norway, we have, if you want good quality data, you have to do it in the actual fjord, because the fjords are so different, the habitats are so different, that what we learn in one fjord is not necessarily true for the next one. So yes, I guess you will need your own data from here if you want to have good quality of what you're doing.
Okay. Well, I would just like to thank you very much for coming all the way up to Iceland to visit us and sharing these brilliant insights from your work. Thank you.
Thank you.